Hey, hello, this is Bob Jackson. I'm here with you with SE 202. This is chapter 15. This is also week 1. Okay, I've already done the one for chapter 14, which I hope you've already completed it. And then you're moving on to chapter 15. On chapter 15, we're going into the Earth structure, okay, in which we're going to talk about, I got a typo I need to go fix on that. Chemical elements. It should be chemical elements. I'll fix it and have it on the PowerPoint fix for you. But going into chapter 15, and it is on their structure. We're going to get into just the very basics of what would be geography and things about the Earth and what makes up the Earth. The main things we'll talk about are chemical elements, some little bit about minerals, not too much, and then types of rocks. Okay, because kids can get into where they collect rocks, and it'd be neat to just kind of tell them the basic types of rocks that we'll get from the Earth. Okay, we're going to go into the internal structure of the Earth, just the basics of it, talking about what the crust is, the mantle, the core, and the inner core are, and then get into the plate tectonics and talk about the crustal plates and how they move and have boundaries, which we get to know as earthquake faults. And then when we go to chapter 16, we'll get to talking about earthquakes and earthquake activity and maybe even some earthquake engineering. Okay, so let's move on through. Okay, the Earth is composed of over 90 chemical elements. Okay, back in chapters 7, 8, and 9, and 10, we covered chemistry and got into the chemical elements predominantly in chapters 8 and 9, and worked with the periodic table. On the periodic table of elements, you've seen there's 118 elements as we know it today. Only 90 of them are naturally occurring. Okay, you're only going to find 90 of those elements in the Earth. Okay, or mine them out of the Earth, use them for whatever. The rest of them are man-made or synthetic, okay, in which we made from the other elements. Okay, now then, of these elements, there's only about 8 of them that are found predominantly in their surface. Okay, and that's about 98% of the Earth's crust, which is what we're living on. None of us are going to see the inside of the Earth deep within it, I don't think. Okay, but 98% of the Earth's crust is made up of predominantly 8 chemical elements. Okay, there's a little bit of all the rest of them. Okay, but predominantly 8. Okay, and of those 8, I can pick out 2 that and can say that's 75% of everything in the Earth's crust has those elements in it. Okay, and that's oxygen and silicon. Okay, now that's not saying I'm going to dig up oxygen as elemental oxygen. It's going to be in compounds. Okay, like lime, like iron oxide, like copper oxide, zinc oxide, and different compounds. Okay, the same thing with silicon. And in order to get silicon in its pure form, I've got to go through a process because I'm going to find it in the Earth's crust as like silicates. Okay, which is by far the most common, where it is in a compound. Okay, it's not digging up just straight silicon or just digging up oxygen. Now, oxygen in its pure form is in the atmosphere and we need it to breathe. There's about 21% there. Okay, in the atmosphere at all times. Okay, but if we dig something up that has oxygen in it, like a lime, then it's still got oxygen in it. We just don't know it as oxygen. We know it as an oxide. Okay, and then we're going to get into talking on different types of rocks, a little bit about minerals. And from minerals and rocks, we get a lot of the metals. that we use every day, like iron and copper and gold and silver, okay, zinc, okay, titanium. They use titanium in a lot of things today. All those metals come from rocks and minerals in the earth, and we mine them and we process them at smelters and industrial plants. Okay, so moving on here. The 8 most abundant elements making up the earth are right here: oxygen, silicon, aluminum, iron, calcium, sodium, magnesium, and potassium. Okay, the predominant two, as I was saying, is oxygen and silicon. About 75% of the Earth's surface has these in them, silicon and oxygen. Most anything you dig up out of the earth will have some silicon in it or oxygen. Okay, not known as then, like I said, it would be oxide or silicates. Okay, but then you bring it on down here, like aluminum's 8.23%, down to potassium 2.09%. Okay, but these will be in compounds. Most of the time, I mean, you're not just digging up a pile of sodium. It's just not going to happen. Sodium's extremely reactive. You'll find it's like sodium chloride or sodium oxide or sodium bromide. Okay, same thing with calcium. Okay, you're going to find it in lime, calcium oxide, and so forth. Okay, now some other important ones is like hydrogen. It's not on this list, but hydrogen's in a lot of things. But it's a lightweight. It's the smallest element of them all, has very little mass, so that's where it's not accounted. So that much because of its mass. But hydrogen is in water and all organic compounds. Okay, so hydrogen is important too. Okay, and there are others than on this list, but these are the 8 prominent ones. Okay, and about anything you dig up is going to have these, at least one of these elements in it. Okay, and the primary two being oxygen and silicon. Okay, so now then, moving on here, we'll go to types of rocks. Okay, there are 3 major types of rocks. There's igneous rocks, sedimentary rocks, and metamorphic rocks. Okay, now then, this is where if you go outside, if you go hiking, if you go for a walk through the woods, if you go walk down a creek, you're going to find rocks. Okay, and all the rocks that you find are going to be one of these 3 main types. They're either going to be an igneous rock, a sedimentary rock, or a metamorphic rock. Okay, igneous rocks are cooled and hardened magma. Okay, so it comes from volcanic activity, or it comes from where magma comes from underneath the earth through the crust and got deposited on where we find it. Okay, and there's various ways this can happen through earthquakes and through volcanic activity. They're primary ways. But you can find igneous rocks at a lot of places, like I say, in creek beds and in the mountains, hiking up a trail, and woodlands everywhere where they've been brought to the surface. Okay, sedimentary rocks, on the other hand, are formed on the Earth's surface, and they're formed from layers of material layering out on the rocks, okay, through time. And it can be various materials from, like coal, bituminous coal is from plants. Okay, it is a sedimentary rock. Okay, that has some value in the fact that we can burn it and make electricity. Okay, so, but chalk, limestone, these are all sedimentary rocks. And if you actually take a look at them, you can see that they're layered. Okay, but they are formed on the surface of the earth. Is the main thing. They're made from different sediments. The different sediments that make them up determine the characteristics of the rock. Okay, metamorphic rocks, metamorphosis means change. Okay, they're rocks that change from what they were. Okay, metamorphic rocks were at one time, and it could have been over a million years ago, either an igneous or a sedimentary rock. They were pulled underneath down into the earth and put under extreme heat and pressure, and they changed, okay, and formed what we call metamorphic rocks. Okay, and you will see, like the metamorphic rock, you'll see that once upon a time they were a layered out rock. They were this was no doubt a sedimentary rock, but it changed its characteristics as it was hardened and put under extreme heat and pressure. Um, and sometimes they can be real glossy and real shiny. Okay, because of that pressure put on them, and it gives them a unique look. So let's take a look at some rocks. Okay, here's some igneous rocks. Okay, andesite, basalt, dolerite, gabbro are granites. Some of the most important ones to businesses anyway, and what people like in their kitchens. Granite countertops. Okay, granite is a type of igneous rock. Okay, and when you look at granite, it is a pretty typical igneous looking rock. You don't see layers there, but you see, like this polka dotted, you see the embedded materials there where it was all hardened together in like a magnet form. Okay, and there are several different types. This isn't the only here. There's all kinds of granite, and you'll find different granites in different areas of the world. Okay, but then like your obsidian, and I don't think these are spelled right, and I pulled this up. I don't think D should be there. It's obsidian, like you have black obsidian, you got green obsidian, almost looks like glass. Okay, but those are types of igneous rocks, pumice, in which they actually take this and make abrasives and stuff to actually for cleaning. Okay, rhyolite. Okay, these are all igneous rocks, and there's a whole bunch of others. These are just some of the common igneous rocks people collect. Okay, and then some sedimentary rocks here, like I said, and I know this is spelled wrong. Bituminous coal, that should be an I right there. Bituminous coal, okay, which is important in the Midwest because our power plants, we've burnt coal for decades and decades. Okay, it's been an important power provider. Okay, we're working our way from it because of the greenhouse gases. Okay, but chalk, limestone, like the white rock we have on our driveways in the Midwest so much. You have a big quarry over by Cloverdale, Indiana, where they quarry, they bring up limestone not so deep in the ground. They're mining it, but then they break it up. Okay, they have huge, essentially rock crushers, and create different size aggregates from breaking the rock up. Okay, and that gives us our white rock for our driveways. But you can tell students that's a sedimentary rock. Okay, sandstone you can find in different areas is sedimentary rock shale. Students can find shale in a lot of the rock in a lot of the streams around here if they get out there in the woods like we used to as kids. I know kids don't do that as much anymore. But you can find a lot of shale. You can also find a lot of shale around a lot of old coal mines. A lot of old coal mines scattered around Indiana. Okay, but they bring a lot of shale to the surface of the ground when they mine. Okay, so that's sedimentary rocks. Okay, and then we go to metamorphic rocks. Anthracite, gneiss, okay, are pretty common ones. Okay, you see it's kind of got a glossy look to it. You can tell the gneiss here would look layered, but then it was metamorphosized into what we call the metamorphic rock. Marble black, marble green, a lot of these marbles, okay, and which marbles become important too in industry for making countertops and quartzite, okay. I know a place out in Colorado where I used to go up on a mountain ridge, and I've got all kinds of quartz rock, actually in flower beds at home that I brought home from Colorado. Okay, but those are all types of metamorphic rocks. That was what you could show students. Or you could even have students bring some rocks in and work on identifying them somewhat together. Okay, that's the three types of rocks: metamorphic, sedimentary, and igneous rocks. Okay, and a little bit about them and some examples. Now we go to layers of the earth. Okay, if we look at the earth, we go from the inside out. We have the core, in which we have the outer core and the inner core. Okay, they're both made up of the very same thing, except they're in a little bit different state. Okay, the inner core is solid. The outer core is a liquid. Okay, and these can be several thousand degrees Celsius hot. Okay, and I don't know that you have to memorize. They got 5,500 degrees Celsius down here for the inner core. It is hot. Okay, and then the mantle is a semi-liquid, and you have a lot of magma in it, and that's where, with action going on Earth, you got some rock being made back into magma through time. Okay, and you have convection cycles. Okay, but there's a semi-liquid layer. Okay, that the crust floats on essentially. Okay, the crust is the thinnest layer of the earth, but the crust, and it's so hard for kids to imagine this, can be up to 30 miles thick. Okay, the part that we're walking on, making up our continents and all, are the thicker parts, whereas under the oceans, there are thinner areas where it can only be a few miles thick at the deepest part of some of the oceans. Okay, but that's the crust. The crust is the thinnest part, and the mantle, and then the outer core, inner core. Okay, now an activity you can do with students is create a model of the earth. And I will have an activity put into the course that you can look at as a hands-on activity for possibly doing with your students in the future. Okay, in which you actually make a ball and then layer it. Okay, and then you actually go to whatever extent you want to create your continents on the outside. Okay. Now, plate tectonics, we go to plate tectonics. Plate tectonics is a theory. Okay, it is a theory about what's going on with the crustal plates of the earth. Okay, it is just a theory. Okay, and proven it probably more true through time. But the biggest thing to teach students, it is a theory. It is a good educated guess of what's taking place. Okay, but the main theory is that you have these crustal plates. If you're looking on the slide, there are several different plates that make up the entire Earth, and these are riding on the magma of the mantle and actually kind of floating and moving through time. Now it's only millimeters or centimeters at a time through years. Okay, and there are only a few basic movements that it undergoes, and that's what we're going to get into. Okay, the first thing to know is there are 7 major crustal plates. You have the North American plate, the Eurasian plate, the African plate, the South American plate, the Indo-Australian plate, and then the Pacific plate, which you see part of it over here and the other part of it over here. Okay, those are the major plates. Now you'll see that there are several smaller plates scattered here and there, embedded within these. Okay, and like the Caribbean plate here, that's where the Dominican Republic had a major earthquake here a few years ago. It was along this fault line here. Okay, and there would have been a Caribbean plate and the North American plate that had interaction going on there. Okay, but the main thing though is the 7 major crustal plates. Of course, the main continents lie on the crustal plates that they're named after. Okay, and it goes right along with any geography lesson. Okay, so if you notice the Eurasian plate has Europe and Russia and China pretty much on it. Okay, but now then you get out here, and then you get this out here where Japan is. Okay, you get a change in the plates, and that's why there's so much activity earthquake wise in Japan. Okay, just along these fault lines. Okay, for us out here in California. Okay, where these major fault lines are. Now then, around this is the Pacific Rim, and they call it the Ring of Fire. One thing I'll get to talking about, you see a whole lot of, even up here in Alaska and down through here, up here in the Oregon and Washington, old volcanoes. Okay, and you get some active volcanoes down here in these areas. Okay, the Ring of Fire, and they're there for a reason. What's going on those plates? Okay, but this, like I say, this can be called the Ring of Fire around this whole area. Actually, all over to Japan and around through here, you got all kinds of big old volcanoes. Then out there in the middle, which you can't really see on this out of here, because they got it cut off, is Hawaii. They're volcanic islands. Okay, and going on. Okay, we have 3 different boundaries that form between crustal plates. Okay, 3 major different ones. You have divergent boundaries, transform boundaries, and convergent boundaries. They all 3 move in distinctively different manners. Okay, divergent boundaries move apart. Okay, they're moving like this, slowly through time. Those predominantly take place, the major ones are below the oceans, like the mid-Atlantic ridge out in between the United States and Europe. There's Atlantic ridge, and what you see here on the PowerPoint, as that opens up, you're getting magma coming out there and actually creates a mountainous type ridge down through here. Okay, and that's that magma coming up and being layered out here, creating mountains. And you can get in a place where it's high enough when you have islands, and that's what the Hawaiian Islands are about, although they're in the Pacific Ocean, not Atlantic. Okay, but that's divergent boundaries. They're pulling apart. Okay, then you have the transform plate boundaries. They're moving like this. They're moving like this. They're moving like this, moving like this. Okay, now they move very, very, very slowly. Now, if they're moving, then they get caught on each other like huge pieces of rock get caught on each other, build up pressure, build up pressure, build up pressure, build up pressure for years, even decades. And then all of a sudden, the rock breaks and they move suddenly. That's an earthquake. Okay, and the earth shake. I mean, that shakes things up big time. Some of them can be huge. And that's what the San Andreas Fault is out in California. Okay, it's a transform plate boundary. So then plates are moving like this, and they can tell, they can measure this movement. If it's been stuck for a while and hasn't moved, they know there's the potential is building for a pretty good sized earthquake. Okay, and they can particularly tell it with the transform boundaries. And then the last type is where you have your plate, here's a plate, and they move towards each other. And one is actually ate up by the other, where it moves down underneath. And this, what was on the surface, goes down and underneath the earth into the mantle of the earth. Now you can also get on these some magma activity and volcanic activity and get volcanoes formed along these convergent lines. Okay, and that's what happens on the Pacific Ring of Fire. Okay, where you get like out on the west coast, all the way up to Alaska, there's several volcanoes and even some volcanoes that are active in Alaska because they're on that Pacific Rim. Okay, and you call these convergent boundaries, and they also can result in forming mountains through time. Okay, and that's your 3 main types of boundaries. Okay, between crustal plates. Now, I'm not going too much more into it on this chapter because chapter 16 takes us into earthquakes, and that's where I'll cover earthquakes more in depth and how we measure earthquakes and look at earthquakes and so forth. So that wraps it up for this chapter. I thank you for listening to me. Have a good week.